In this video, we'll study electrical conductors and electrical insulators. Now, first, you know atoms. They have protons inside that are positive, neutrons inside the nucleus that are neutral, and outside they have these negative electrons, don't they? In every substance, atoms can lose electrons more easily than they can lose protons. Protons are stuck inside here pretty tight. These, though, can come out occasionally. For instance, let's say this one down here came out. This guy leaves the atom. See, now he's out here. Electrons that leave their atoms to roam free, we call them free electrons. So this would say steel. This electron's out here to roam around and do things for us. Turns out, of course, because this guy was neutral before, the atom was neutral before, now it loses a negative. It ends up being positive, doesn't it? We call this an ion. Since it's lost an electron, this is a positive ion. Of course, down here we have the negative free electron. The atoms of some substances give up electrons easily. They have many free electrons. Here's steel. It's true of all metals, pretty much. Steel has all these electrons. These are all free electrons. They're roaming around inside of steel. Many free electrons in steel. How about wood, though, do you think? Wood has very few, if any. The electrons just don't move around much in here. So wood has very few free electrons. All right, so let's take that steel. Let's say we connected him to a battery here. This is the positive side, so the electrons are going to come out of here, go along that wire. When they get to here, and if they're going to find in here, plenty of free electrons. So this guy here is going to force that electron here inside the steel away. He's going to start moving. And he's going to force the next guy all the way across the steel. And because there are many free electrons, this electricity can come through and go right through here, and we're going to have a nice strong circuit. Plenty of electricity going through this circuit. But how about with the wood here? This thing has so few free electrons that the battery is going to try. It's going to send them to here. But once it gets to the wood, there's almost none of these guys to push along. So maybe a little bit will come out, maybe almost nothing. So we can see the difference here. Here, plenty of free electrons to push. They are pushed across. Plenty of electricity here flowing through this circuit. Over here, very little and perhaps none, because there just are very few free electrons here in wood. So we call these things here the substances like steel with plenty of free electrons where electricity will flow. We call those electrical conductors. Wood is an example of an electrical insulator because the electricity will not readily flow through it. Conductors and insulators. Flow of electricity, yes. No, almost none here in an insulator. Now here's an example from class. You remember our Van de Graaff. Turns out the Van de Graaff generates an incredible amount of positive charge up here. Positives, those are ions, by the way. Those are air molecules that have lost their electrons. This is really positive here. We attach that to what's called a discharge wand, which we'll use to take all the charge off of here. Now, this is not touching anything, so nothing's happening. Notice this is made of steel, let's say. Now we touch it. We have a circuit here now, so that the positive charge will flow. This is a pipe that's, say, attached to the ground in your house. It'll flow into there and flow right down to the ground. But what's the problem, though? Why does this guy say, ouch? That's because some of the electrons, the positive charges, go into his hand. It hurts, sure. But what happens then if we take that same discharge wand and I wrap it in cardboard? It's hard to see. Do you see the brown there? So now this hand is holding the cardboard, not the steel or the metal. What's the hand going to say now, do you think? Well, he might say, no problem, no pain at all, because that cardboard is an insulator, isn't it? The charges come down here, go through the steel inside, but they can't get through the cardboard, so the hand experiences no pain at all. The most common example of a conductor and insulator, of course, is just regular wire. We have an insulator on the outside, conductor on the inside. This guy can grab this with no problem, no pain. Your video code is insulator. I do have time to do this. Conductors, metals by far the most common. Wood and plastic are insulators. Tap water is a conductor. Air is an insulator. Cardboard and rubber. By far the most common conductor is metal, and almost all conductors are metal. These things don't flow. Electrons don't flow here, and I gotta say goodbye right now. Bye.